Okay, great. Sounds like the audio is clear and coming through, so that's fantastic. Thank you, everybody, for joining us today. We are going to be featuring Dave Haeffner, a Selenium and test automation expert, as he talks about how to build simple and powerful automated tests using readily available third-party providers like SoftLabs, Applitools Eyes, and CloudBees Jenkins platform. They've all provided an expert to be available during this webinar today as well, so they may chime in during Dave's presentation if there's something specific, and they will be available during the Q&A at the end of the hour. We have a lot of people on the line today, so if you're having any technical issues, you can contact me in the chat panel or in the Q&A box, and I'll be there to assist you. The Q&A panel is also the best place to submit questions that you have as we go through the presentation. We'll get to as many as we can in the last 15 minutes of the hour with Dave and our testing experts there on the line. If we can't get to your question, we'll have the right expert follow up with you on an answer after the webinar. We are recording this session today as well. Once it is ready, you'll receive an email with the link to the recording and slides. You should expect that by tomorrow or the next day, absolute latest. With that, we're going to go ahead and pass this over to Dave Haeffner. Thanks, Dave.
Great. Can you hear me okay?
Yes, we can.
Okay, cool. And slides are working, I'm assuming.
Yep, I see your agenda.
Okay, cool. Thank you. So let's get started. This is automating awesome test automation made simple. And so this is a four-part play. The first act is getting started with powerful tests using some open source tooling and a commercial solution. And then we'll then move into taking those tests and running them on any browser and operating system combination. And then we're going to show how to automate your test runs using continuous integration. And then at the end, there's going to be a Q&A panel. And when we get to that, I'll introduce everybody on the panel. So Act 1, getting started. Selenium and Applitools Eyes. So let's start with Selenium. Selenium is an open source browser automation tool. It's kind of the de facto option as far as open source test automation is concerned. And it works on every major browser, operating system, and programming language that are out there. And the main thing that's really cool about it is that it mimics human action. That's the main focus, the main strategy, and that's fundamentally the perspective that you need to have when using the tool. And it uses a few common actions, which I'll cover in just a slide or two. And it works with locators. And locators are what tell Selenium which HTML element on the page a specific command you're using refers to. And so there's different strategies is what they're referred to in the documentation. All these 7 here, class, selectors, IDs, et cetera. And it can be overwhelming if you're just getting started as to how to wade through this and what this all means. But the thing to think about is that good locators are unique, descriptive, and unlikely to change. And that rules a few of these out. Really, you should start with IDs and classes. Those are the most likely to be helpfully named. And they're also the most performant of the locator options within Selenium. And then, if you have those harder to reach parts of the page, then use CSS selectors or XPath. But be sure to practice care when using them because it's very easy to make brittle locators that are slow using CSS or XPath. And there's been some controversy over the last several years within the testing community around which is better, CSS or XPath. And some old benchmark data was cited. And I went back and retested those benchmarks and found that there's actually a negligible difference between CSS and XPath performance. There are a couple of edge cases to that where one is clearly better than the other, but those are for old browsers and for locators that you really shouldn't use. So at this first link, there is the benchmark write-ups that I have. And then if you want to see a comparison between CSS selectors and XPath, the second link is a good resource for that. The general advice I give for people is if you have a preference, go with that. And if your team has a preference, go with that. In terms of finding locators, if you've never done this before, The good news is that every modern browser comes with the capability to inspect a page and find elements within the page. So if you want to inspect the page, you just right-click within the browser, inspect the page, and then you can actually see what markup exists on the page and find your locators that way. And then once you do that, you can also verify your selection. And the more I'm trying to debate whether to say it's not really the new cool kid way, and it's not really super old, but it's not new. But there are plugins that exist for browsers like FirePath and FireFinder, which are add-ons for the popular development plugin tool for Firefox called Firebug. And it enables you to easily drop a locator into an input field, and it will highlight on the page the locator that you're referencing, just to make sure that you have the right one. And so it's doing what you think it's going to do before you take the effort to write a test and plug in the locator. Alternatively, the more modern-ish way is to just leverage the developer console and just type in some jQuery code, or some browsers like Chrome have this feature already built in, and there's just some specific syntax for that. I have a write-up on how to use FireFinder at this link here, if you're curious what that looks like and how to use it. So some common actions that mimic human action with Selenium. These are the most common ones that I run into on a daily basis, and these are the most common ones that we're going to start with just to get our tests working. The most popular and prominent one is always going to be the first one, find element. You first have to find an element on the page using a locator before you can interact with it. That's fundamentally the ebb and flow of any test you write with Selenium. You have to find an element, then you do something with it. And then you also have to do something once you find that element. You can click, if it's a button, if it's a link, etc. If it's an input field, you can clear what's in that input field and then type keys into it, or send keys. That's the command for typing. And then you can actually get information out of the page. You can get the text of something. And then you can also ask questions. You can see if something is displayed. And when I say displayed, I don't just mean like a simple check to see if display none isn't listed in the page. It actually, under the hood, is doing a series of checks to, as close as possible, mimic the human eye. It's trying to actually determine if an element is actually visible to the end user. And as far as the syntax is roughly the same from language to language, but if you're using a different language than what I'm going to cover, be sure to check what the actual syntax is for your language bindings at this link. And so using this pattern of finding something and then taking an action, here's what an example would look like if you're going to log into a website. You would first have to visit the page. And one action I didn't cover was how to navigate to a page. The command for that is get. So you would visit the login page, and then you would find the username input field of the login form, and then you'd want to input text into it. You'd then want to do the same thing for the password field, and then you'd want to find the submit button and click it. Alternatively, you could actually find the form and just submit, which works, but it doesn't actually mimic human action, so I try to steer towards doing actions like this, like finding the submit button and clicking it. And so I have an example on this open source repo that I have called the Internet. At this link here, you can see it and play along at home if you want. But this is a snapshot of what the page looks like. It's just a simple login form with a username, password input fields, and then a login button. And so here's an example. For these examples, I'm just going to showcase using Ruby, which is a prominent scripting language, which reads a lot like English. And the reason I choose that is because it's the most approachable language I've found for people regardless of their technical background, either people who are just getting started with no programming experience, or people with an abhorrent amount of programming experience well beyond what I could ever strive for in my lifetime. So it just splits the difference, levels the playing field. And then in Ruby, if you're doing testing, RSpec is an open source testing framework which has pretty much everything that we need out of the box to get started. So let's get started. Here is what a simple test would look like using RSpec to take care of those Selenium commands I just showed you. So at the top, we are requiring Selenium WebDriver. That's the library for the actual bindings for Selenium for Ruby. And then there's some RSpec-specific syntaxes going on here words like describe, before each, after each, it, do, those are just RSpec-specific things. RSpec is referred to as a behavior-driven development framework. It's supposed to read a lot like English. So the main parts to know is at the very top when it says describe and then it has a string, that's just the name of the test class. And we're able to specify it using a string so we can actually just name it whatever we want. And then the before each and after each is our test setup and test teardown. So in before each, we are creating a object, which is an instance of Selenium. And in this case, it's creating a browser instance of Firefox. And I'm choosing Firefox here just because Firefox is the browser that comes out of the box available with Selenium. There's no additional setup required. It just works. And then after the test, I'm quitting the browser, which means it's closing the browser session. And then this it block is actually the test. I'm just naming it something helpful for the happy path case here, which is succeeded. So I have to get a URL, and the URL in this case is on the Heroku endpoint that I have for my app, and then it's the login page. So it goes and visits the login page, and then I find element on the ID of the username input field, which I would have found if I had right-click, inspected, and looked for it. And then once I find it, I send keys. And the username is Thomas Smith. And then the password is super secret password. And then I find the button and click it. And then the thing that's missing here is arguably the most important part, and that's the assertion. And the comment here where it says assertion goes here. Assertions are the most important part of a test, aside from actually the actions taken to get to the part where you need the assertion. Because without an assertion, it doesn't actually tell you if it worked or not. And so this is where I think the crux of this happens is without an assertion, we get nothing. And then doing assertions really well is hard. The normal way to do it is to inspect the state of the page at the end of the workflow, and then find something that has helpful markup that shows the page is in the state that you want. And then find some way to assert that the page is the way you want. That can be very brittle. It can be very challenging to make assertions actually test what you think it's testing. It might not cover all cases. It might be brittle. And this is where automated visual testing really fits this niche really well. And so automated visual testing, let me stick with this. So automated visual testing with Applitools Eyes is actually the way to go. And it's really interesting. Automated visual testing for a few lines of code will give you hundreds of assertions. And really what it's doing is it's checking the visual layout of the page. And to catch visual anomalies and verify content. It'll catch visual bugs like font, layout, rendering issues. And then if you had more complex things on the page like charts and dashboards and stuff, you could also check that. But the cool thing here is that instead of actually looking at the page at the end state, finding an element and then seeing if something's displayed correctly by asking Selenium if it's at least visible to the human eye, you can actually effectively put a human eye that's a machine ultimately using Applitools Eyes. And so what that looks like is a few lines of code here. And so what we've done is we've required the Eyes Selenium Ruby SDK. And so that's the Applitools Eyes SDK. And then we've modified our setup. And in the setup, the things we have to change are we have to create an instance of Applitools Eyes and then add our API key. And for the API key, I'm actually, in my case, using an environment variable on my local machine. But if your preference is to hard code the value here, that's something that you can do as well. And then after that, I'm creating an instance. I'm passing an instance of the browser with Selenium to Applitools Eyes, and then getting a browser object back. And so when I'm doing that, I'm passing in the app name and the test name, which will be helpful in the job dashboard in Applitools Eyes. And then the rest of the test is fairly straightforward. The teardown is the same as before. And then the test is actually where we put this to use and we get value out of it. So now that we have a Firefox instance running on our local machine, but it's passing through Applitools Eyes, what we're able to do is create checkpoints in our test where Applitools Eyes can take a snapshot of the viewport in the browser and compare it to a baseline image. And if there are any anomalies, if the page does not look like it should in its desired end state or at states throughout our workflow, it will fail the test, and it will give us a link to the job and show us the differences in the images between what reality is now and what was expected. And so the way we do that is right after visiting the page, before logging in, we can take an image of the login page. We're using the check window command. And then after logging in, we can do check window again to show the logged in state. And then after that, we call eyes.close. And what that does is it triggers the check windows to be compared against the baseline and perform the final check ultimately. And so what that looks like, if we run it, is this. So it loads the browser and then connects, completes the test, eyes.close happens, and then once this is done, it outputs here. If there were a failure, or if this were the first time it would run, it would give us some output here, but we can just hop into the dashboard, and we can see that it passed. And we can see this compared to the previous baseline that I had already created. So that's just really quick and simple. And as we progress through this, there will actually be some failures that I'll show, so I can show the Applitool is actually catching those. So just to recap really quickly, assertions are the crux of an automated test. And automated visual testing gives you hundreds of assertions in just a few lines of code. Automated visual testing is something that's really cool, I think, is probably the most interesting of automated testing technologies that exist right now, and is something everybody should consider because it automates something that used to be done manually and people think still needs to be done manually. You can actually you can take a look and feel of a website and visual anomalies that used to have to be checked with some manual visual regression checklists at the end of a development workflow, and then you can push those up further to the front and ultimately get more powerful automated tests in general by using them to perform assertions. And it's worth noting that there are over 16 open source solutions available for doing automated visual testing. And with each one, there are limitations. There's false positives and things like that. And I've tried most of them. And as everything I've tried, Applitools is the one solution I found that can actually address these false positive limitations without having to resort to tweaks that ultimately lead to more headache later on. I actually have a full write-up at this link here that talks about all the available open source tools, step through some examples with them, and then progresses into follow-on posts that talk about the different false positives, ways I've tried to address them, and how Applitools picks up the slack. So it's worth a read, I think. So moving on, Act 2, any browser. So Selenium with Applitools Eyes is great, except we're only running our tests on Firefox right now. So we can add in Sauce Labs. Sauce Labs gives us access to every browser and operating system combination that we can think of. And also, just like with Applitools Eyes, it's done with just a few lines of code. So an example. If we take the previous example we just built on and make some additional modifications to our test setup, this is what it looks like. So if you're new to programming or this concept of using a third party, this might be a little bit overwhelming, but let me step through it piece by piece. So the first block of code here, the first chunk, the first 4 lines and before each, we're using what's called a capabilities object. So in order to run Selenium at scale, you need to use a Selenium remote instance to point at a grid that has the browser and operating system combinations that you want. And to do that, you need to use a desired capabilities object. And in this case, we're creating one for Internet Explorer. And what that does is when we connect to Sauce Labs, it tells Sauce Labs that, hey, I want an Internet Explorer browser. And then with that object, you can add additional things like the browser version of Internet Explorer. So in this case, I'm asking for Internet Explorer 8. And then the platform I'm specifying is Windows XP. So I want a browser instance of IE8 on Windows XP. And I also want to make sure that my Sauce Labs job has the correct name when it runs. I want it to be the name of my test. So that's what's happening in that first block. Second block is how we're actually connecting to Sauce Labs. And so we have to specify our credentials, just like we did with Applitools Eyes with the API key. In this instance with Sauce, we need to have our username and our access key. And it's behind basic auth. So I create this little credentials object. And then I use it to point at Sauce Labs and hit their on-demand endpoint, which is at the URL specified there. And then I'm passing in the desired capabilities object I created in this first piece. And then the Applitools Eyes stuff is the same except for the test name. I've modified it so it's dynamic now. And so it's just passing in the full description. Other than that, it's business as usual. And so what that looks like when I run it is this. So the browser execution is not happening on my machine, like it's not actually loading an instance of a browser. It is running Selenium, but what it's doing is actually firing up a job in Sauce Labs while also connecting to Applitools Eyes. And if we look at the job, we can actually watch a video of it playing out as it's being run. And this video gets recorded and is available after the fact, as well as screenshots and all the commands and all the logs that happened with additional metadata like the platform and the browser, et cetera. And then once it finishes, it'll output information here if there was a failure. And in this case, it actually found that failure with Applitools. And when that happens, it'll display a URL to the job. But if we just go to the task dashboard, we can see it. And we can open up the job. And if we do a comparison, we can see that the iconography, something within the actual success notification after logging in has gone remiss. It's no longer there. So in this case, it was a check mark, and now it's no longer there. And this is something that's maybe fairly trivial, but if we were using an assertion the traditional way, what I would have done would have been to look for this flash success message and made sure that it was displayed, visible to the user. And the issue with that is that it would have missed this verification, whereas Applitools Eyes was able to pick up the slack here. So to recap, you can run your tests on any browser and operating system combination that you need. There's something like 500 available at last check. And then, again, it's just a few lines of code to do this. And then you get great reporting. The big thing, I think, is the video recording that I could showcase quite a bit. There's some additional stuff, which I'm not going to go into, but if you actually had a test instance that's running at a crucial point where you wanted to get in and do some debugging, some manual review, there's actually a manual inspection where you can take over the session and then control it by hand. It's pretty cool. But if you want kind of a more in-depth romp through Sauce Labs, how to set it up, I have a full write-up here at this link. So, Act 3, automated test runs. Selenium with Applitools Eyes and Sauce Labs. It's an awesome start. The issue here is that now we have everything we need to actually do some really powerful testing, except that I'm running them manually. So it would be much better to automate them. And to do that, we can use CloudBees, the CloudBees Jenkins platform. So a real quick primer here for those of you not familiar with continuous integration. So a continuous integration server is also known as CI. It's responsible for merging code that's actively being developed into a central place, often referred to as a trunk or a master. And then this is frequently, i.e. several times a day or on every code commit, is compiled and combined to find issues early so they can be addressed quickly. This is all done for the sake of releasing working software in a timely fashion. And with continuous integration, we can automate our test runs so they can happen as part of the development workflow. And the lion's share of tests that are typically run on a CI server are not Selenium tests, but unit tests and potentially integration tests. But we can very easily add in the tests we just wrote to continuous integration. And so really what continuous integration, aside from a textbook definition, what it means to me is that it offers feedback loops. It offers you a mechanism to offer feedback to the team, either a team of other testers or potentially the developers that you're on the team with. And it also sets you up for the ability to do code promotion and moves you, closer and closer towards continuous delivery if you're not already there. And so by feedback loops, what I mean, the goal here is to find failures early and often. And the way to do that, I think, is to enable notifications after you've automated your test runs to make sure that the right people get notified when something is broken. And the easiest ways to do that are things that are readily available, like email, chat, SMS. There's integrations for CloudBees and Jenkins to enable that very easily. And then there's also ways that you can send notifications to things that are within the co-located space that you may occupy with your team, audio-visual indicators and things like that, like glowing orbs. I've seen traffic lights wired up. I've seen a bunch of different things that people have done that can really work for the team and make it something that's part of the fun and the community that they're building. And the way that all works, though, is tied to this novel idea I have of code promotion. And here is kind of a real simplified version of what that means and what that would look like. So say, for instance, code is committed by your developers on your team. And then on the continuous integration server, integration happens. The code is integrated from various parts of the code base. Does that integration pass? If yes, then deploy to an automated test server. And by that, I mean a controlled server where only automated tests are able to be run. And if that deployment is successful, then run the automated tests. And then if those pass, then you can deploy to either a manual test environment or to the next environment, acceptance testing, staging, mock-up, or even if you're feeling feisty, just go straight to production. But really, this is kind of what you get by having code promotion enabled by automated tests plugged into continuous integration with good notifications. So notify the team if none of these are actually working. And then bonus points if you actually can get to the point where you're stopping the line. You're actually making it so nothing can proceed until the issue that's been brought up, that's been notified to people, is fixed. So Jenkins in CloudBees, the simplest way is to create a job. And here are the 7 steps to set up a job really quickly. So you first create a job, and then you pull in your test code. And your test code can be in any number of places, but the best place it should be is in a version control repository. And then once you have that pulled in, you set up a trigger. And then when that trigger happens, you want to make sure that the job builds. So you configure the build steps. And then ideally, your build steps will run the tests and then output some sort of report. And so you want to configure this job to consume those reports. And then afterwards, you want to set up some sort of notification. And notification integrations are easily handled within Jenkins by installing a plugin of some kind. And then after you do all that, you run your tests and view the results and make sure that they work as you thought. So let's just step through a quick example. I've already pre-configured a Jenkins instance so that I don't have to fumble through this in front of you guys. But what that looks like here is a configuration of the job. It's this decently lengthy page, but at the top here is the project name. And so in this example, I just called it login tests IE8 because that's what we just coded. That's the test that we want to run. And then don't worry about too much of this stuff. This was actually pre-populated as part of the CloudBees instance. The thing that's important here is the source code management. This is how I configured to pull in my repository from GitHub. And the repository is here under my Tour de Dave username on GitHub, if anyone's interested. I'll also link to it in the recap. And so I just plug in the URL, and that's it. It's just pulling from the master on that repo. And then I come down here to the build section. And then in the build section, I add a build step for executing the shell. And then here are the shell commands I have to specify in order to run the tests. So since I'm using environment variables that aren't hard-coded in my test, I want to make sure I'm creating the environment. I'm specifying the values for the environment variables here so that this system has them. And so I'm doing that here. And then I don't actually assume that this system has any of my dependencies for my test environment yet. And so I need to make sure I install my dependency management and then install the libraries. And then once that's done, I run the tests. And then after that, I come down here to the post-build action and click Publish JUnit Test Result Report and specify that it's just XML files. So grab all the XML files that are in the current working directory. And then I save, run it, and once it runs, it ends up, there is a forced failure that I've coded into this. So it shows that this is the test result here. So if you do test result, it dives in, you drill in, and you can see that this login succeeded test has failed. And in the stack trace output, I've configured it so that we get Applitools Eyes, but I've configured it also so we get a Sauce Labs link to the job. So in this case, this is the Sauce Labs link, and this is the Applitools link. So here is the job in Sauce Labs. We have the video if we wanted to watch it. We have all the commands that the test used and all the screenshots that go along with it. Selenium log for additional debugging. And then in Applitools, we can actually take a quick look here at the diff, and we can see that there's two conflicts down here. And there's another issue with the logo on the login button. And then there's an issue with the entire flash message has disappeared, which has caused the whole page to go out of array. And so for these, we can choose to accept or reject them and then save them. And then in future runs, our decisions here will be respected and used for future runs. And so to recap, you can automate your test runs without infrastructure overhead by using CloudBees and Jenkins integration. And then you can plug these into the development workflow you're a part of. I didn't really mention too much more than just creating and running the tests, but you can make it so this job runs as either on a schedule or on every code commit, or if a different job were to pass. And if you go back to the code promotion diagram I showed, the thing you would look for would be the deployment action to that protected environment, that controlled environment. And if that were successful, then you would run these tests. And then enable notifications to fit your team's context. So most people use Slack for chat nowadays. There's a Slack plugin within Jenkins for you just go into the plugin manager within the settings of Jenkins, and then you just install it and then plug in your Slack chat information. So that's one example of how to easily enable notifications for your team. And then you can automatically have your tests output links to high bandwidth information. So Sauce Labs and Applitools was the example in the stack trace output I just showed you. And it really makes everything sing. The biggest issue when there's a test failure is diagnosing what the actual culprit was. What's the smoking gun? And the best way to do that is to get as much information as possible. And so by having links to the jobs in Sauce Labs and Applitools, you can quickly and easily jump to the specific test that ran, get the results, and then look at it and find out what the issue was, and then go and fix it. And if you want a more thorough walkthrough of everything I just covered, there's a lengthy blog post with screenshots that showcase all of this stuff at this link here, se.tips/ci-walkthrough. And I'll make sure all these slides are available after the fact as well, in case anyone missed any links. So awesome test automation has now been achieved. So make sure to high five your neighbor when you've accomplished it, because it's, I think, a pretty fantastic achievement. It's if you're just getting started, this is huge. It sets you on the right path to do successful test automation. There's a lot more to think about, but getting this infrastructure in place is a huge, huge step. It's so much easier nowadays with these commercially available tools than what used to have to be done 5 or 6 years ago. And so if you've done this, then make sure to relish the fact, take it in, high five your neighbor, high five yourself, pat yourself on the back. So Act 4, Q&A panel. So I want to transition now into the panel, and I'd like to introduce the people on the panel. So from Applitools Eyes, we have Adam Carmi. He's the co-founder and VP of R&D at Applitools. And at Sauce Labs, we have Abhijit Pendial. He's a solutions engineer at Sauce Labs. And from CloudBees, we've got Brian Dawson, the DevOps evangelist from CloudBees. I'll let Christina moderate the questions and kick them off and let people have at them. But before we do that, I just want to mention that there is free stuff that each of these companies is offering to you guys. And so Applitools Eyes has an ebook that they're offering, which I actually wrote. It's a step-by-step guide on best practices for automated visual testing. And if you want that, you need to send an email to marketing@applitools.com with the word ebook in the subject line. And then Sauce Labs is offering a free 14-day trial with some killer features. The features on top of everything I've already mentioned is the fact that the capacity they're offering. They're offering 8 virtual machines with 90 browser hours with unlimited manual sessions. Just go to this link to sign up. And then CloudBees has an ebook that they're offering. If you're looking to transition from CI to CD, download their book, Making the Shift from Continuous Integration to Continuous Delivery. And it's at this shortened link here, bit.ly/CloudBees-ebook. And I'm just going to leave this screen up here while we dig through the questions so everyone has time to copy this stuff down. Go ahead and take it away, Christina.
Great, thanks, Dave. That was fantastic. We've gotten a lot of questions coming in, and they're coming in really fast right now, so I'm doing my best to kind of go through them. So the first question I see here that was brought up in a lot of different variations is around page object frameworks. So we were asked, do all of these tools work well with page object frameworks?
Sure, I can answer that, unless anyone else wants to grab it.
No, that sounds great. This is for you.
Okay. So page objects have no bearing on whether or not they would work with these services. So it's really just page objects are a way to write your tests more intelligently so they're easier to maintain and faster to write. So if you're using even a third party, like other open source solutions out there, like there's the built-in one within Selenium and Java for Page Factory, there's HTML elements for Yandex, or even if you just create your own, that doesn't matter because what matters is how you're executing your Selenium tests, and all you're doing is you're pointing them at Sauce Labs, which ultimately, and Applitools Eyes, which ultimately is just a wrapper for Selenium. So page objects have no bearing on any of this stuff.
Okay, that's perfect. Next question, let me see here. Can Applitools be used for functional testing as well?
Yes, hi, it's Adam here from Applitools. Yes, definitely. Actually, there are many advantages to doing that. So just to clarify, so although Applitools is the unique value is to find visual regressions that tools like Selenium cannot find, as Dave described, basically it can also be used to test any functionality of the product which is exposed in the UI. So just to give a very simple example, if you have a calculator and you just entered 1 + 1 and it came out as a 3, the tool would pick it up because the 3 doesn't look like a 2, but still it would be a functional bug that is captured and not a visual one. Similarly, if there is some problem with the sorting order of a table, it would pick that up, although it's a functional bug, or if your database query returns a different set of results, then again the tool would pick all those up. And actually there are many advantages of doing that. So first of all, as Dave showed, it's quite easy to write the tests. Each validation point only requires 1 line of code. It covers the entire screen, and there is no need to deal with all the element locators or prepare expected data for them. Second, you get immediate coverage for new features. You don't have to write the code test and find the time to write them and maintain them. As soon as the new feature is available on the screen, you just approve it with a click and it's covered. And it also allows you to find unexpected changes. So with traditional assertions, only the assertions that you explicitly specified are actually checked, also as Dave described. So if your test can succeed, even if there is something broken that you didn't assert on. But with this type of testing, you can also find unexpected functional bugs, which is great. And the last thing is that, as you saw in the dashboard, when you see the results, in order to maintain the test, you only need to approve the new screenshot as the new baseline for subsequent runs, which means that every member of your team can perform this maintenance. As your UI changes, you don't need to go into code and change the test. It's in most cases only sufficient just to approve the new screenshots and you're done. So it's a very effective way to achieve functional coverage for many of the scenarios and functionality of your application.
Great. And real quick, Adam, before you put on mute, we've had several people mention that the marketing@applitools.com email address is not working. I don't know if you have another one you can throw out real quick, or get one before we log off.
Okay, so I'll let you know of one that works.
Okay, great. All right, so next question. Actually, this will be for Abhijit. And we didn't get to this part. So can we run multiple browsers on different platforms all at the same time in Sauce Labs?
Yeah, absolutely. That is the main value that Sauce Labs provides to you, that you could have a single Selenium script or a bunch of a Selenium test suite running against a combination of browser and OS combinations, right? And when Sauce Labs provides you with a browser and OS combination of your mobile platforms of close to 650, that allows you to just set your preferences based on your compatibility matrix and what your users usually access your applications on, and you're able to do that, a test in a concurrent fashion, not only reducing the overall test execution time, but also scaling your testing framework in order to ensure optimum experience across your applications on those platforms.
Great. And real quick here, I got an email address for everybody that was trying to email. It's info@applitools.com, and that should work. I'm just double checking that's what it was. Yeah, so use info@applitools.com. Okay, so moving on, we have a question for CloudBees. The question is, why would I use the CloudBees Jenkins platform compared to just Jenkins?
So and this is Brian Dawson from CloudBees, by the way. So Jenkins, of course, for those that may not be familiar, and for those that are even, is a very powerful open source automation engine or CI and CD solution. One of the things that makes it powerful is that it has 100,000 plus plugins that enable it to integrate with testing solutions such as Applitools and Sauce Labs and Selenium. Within that open source framework, though, one of the things, the flip side to sort of the power of a rich ecosystem is that oftentimes it can be hard to maintain and manage at scale. So what CloudBees Jenkins allows you to do is it extends the base open source Jenkins with capabilities and features that make it easier to manage at scale, as well as we provide support within the product and certified plugins. But beyond that, when you're looking to extend your continuous integration pipeline to include automated visual testing and functional testing, such as that supported by the tools that Dave outlined, CloudBees Jenkins provides you something called CloudBees Workflow and Workflow Visualization that allows you to code up and version control complex pipelines, including achieving parallelism. So, for instance, someone asked in the chat, do I separate functional test and visual test? I think oftentimes because of where they appear in your delivery pipeline and because of the load and the time frame that it takes for them to run, you would separate them. With CloudBees Jenkins, you can use Groovy script within your Jenkins job or CloudBees workflow to very easily script up a complex pipeline with visual representation that will allow you to run long stream, sort of long-running functional test out of band. So long story short is it adds capabilities for managing Jenkins at scale, and it enables creation of complex pipelines that tend to be required in extending what we've seen today in continuous integration to continuous delivery.
Okay, that makes sense. Thank you. The next question, we had this question a couple times too, so I just wanted to address it real quick. And this could be for Adam or it could be for Dave. A lot of people, when you were showing the baseline image, people were wondering, how did you create that to be able to test it?
Dave, do you want me to get it?
Sure.
Yeah, okay. So basically, as Dave shown, every time when you see the report, it shows you the baseline against the screenshot that is being validated. You can choose to accept the new image, and then it will be set as the new baseline for subsequent runs. All we are left with is the initial baseline. So the default behavior is that whenever you run a test for the first time, the screenshots that are taken during that test are automatically saved as a baseline. It is also possible to configure the SDK to just fail the test and ask you to go and approve it manually. So most users will simply leave it on the default. So the first time you run a test, the test will fail. It will indicate that a new baseline was just set, and you should go look at it, but you don't have to do any action. The next time you run it, there's already a baseline to compare against. And from there on, whenever there are differences, you're being notified. You go to the report, you look at them, and if there are valid changes because it's a new version or a new feature that was added, then you just approve the new screenshots.
Great, thank you. Next question for Abhijit. Will the Applitools and Sauce Labs integration work with the mechanism to allow Sauce Labs access to a private environment?
Absolutely. So Sauce Labs is a full service solution, functional testing solution, regardless of the application asset that you're testing, right? So you could have, of course, you can easily test your public applications, but if you want to test any lower environments, especially your QA and staging applications, Sauce Labs provides a simple tool called Sauce Connect that allows you to test those applications in a secure and encrypted manner on Sauce Labs and still leverage all the different combinations, browser noise combinations between mobile platforms that we provide. Yeah, and there are a lot of technical nuances to that too, but the implementation of it is quite simple, and the deployment scenarios are quite varied as well, and it's a very versatile tool, and happy to engage in any subsequent conversations in case you're interested in it.
Great. All right, perfect. On to the next. Again, several people asking about, and I think this could be for Applitools, it could be for Dave, again, I'm not positive, but how do you handle different browser viewport sizes, such as different screen dimensions or something that's less than a full screen?
You can handle that one, Adam.
Yeah, I'll handle that. So basically, whenever you run your test, Applitools queries Selenium to find out in which environment it is running. That includes the operating system, the browser, and also the viewport size. And so you can just use the same code to run in different environments, and the tool will automatically create baselines for these environments and automatically know to which baseline to compare the new screenshot. So there's no changes in code that are required. You already get those baselines set for each of the environments that you want to test on. Besides that, Applitools Eyes is also capable of comparing and doing cross-browser and cross-device visual testing. This means that you can have a single baseline that is set for a specific environment, do a strict regression test on that specific environment, but then use the same set of baseline images to test other execution environments. according to the layout or structure. So for instance, let's say that you have a baseline set for your application running on a certain mobile device, or let's say a certain browser, let's say Chrome, for instance. You can do regression tests on that environment and find minute differences such as a comma changing to a period or a plus symbol changing to a minus or some icon that is missing. But then again, once you've done with that and you've updated your baseline to the new version, you can then use layout matching to make sure that your app renders correctly in all the different browsers without having other baseline for that. And the way that you accomplish that is that you provide a name for that baseline and then tell the SDK by name to which baseline it is expected to compare against. In that case, it will override the default behavior of comparing against the baseline that is dedicated for that new environment, but will rather compare against the baseline that is associated with the name that you've specified. So actually, you can do both regression testing as well as cross-browser and cross-device testing without increasing the amount of baseline images that you need to maintain.
Okay.
And just before I finish, I want to remind everyone that you should send your emails to info@applitools.com and not marketing. info@applitools.com. Thanks.
All right, perfect. Okay, next question is for Brian. Brian, the question is, in your CI terminology, you mention something about integration tests. Could you please clarify the definition of integration test? Does it belong to the combination of JUnit test and Selenium?
Okay, unmuting. Thank you, Christina. Yeah, so I'll start answering this, and then maybe Dave can feel comfortable to could chime in if he'd like. So integration test traditionally means whatever level of validation is required to get a high level of confidence that the developer introduced change has not compromised the integrity of the application. Traditionally, that would mean component level test executed via JUnit. Usually, you're going to target in CI to have a very tight CI loop, i.e. once a developer commits, your CI build and validation should run inside of 5 minutes. Usually that limits the level of testing and validation you do to unit test and some level of code scanning. Once your integration tests succeed, as Dave outlined in his table stake CI diagram or fundamental CI diagram, you can then deploy and promote that build to do visual testing, functional testing, security scans, etc. The reason that you would traditionally save the visual testing, functional scans, etc. to a later promotional stage is not always, but oftentimes the act of deploying, setup, and mimicking users' behaviors will take more than the ideal time required for the CI loop. That said, there's general guidance and practice that said you would focus your component test and the integration test, but there is no one-size-fits-all. In an ideal world, you can accommodate or you would include as much automated testing and validation as you can in that initial CI loop.
Mm-hmm. Okay, that makes sense. Oh. I just put you on mute, Brian. I think we were echoing. Dave, I'm going to ask you a question as the expert here. We did get a lot of people, we always have different levels of people joining us, and, we had some people saying that they're really new to test automation. They've been mainly doing manual testing. Coding is not quite yet their strongest point, and they're wondering kind of how to get started and what that would look like, how much, they need to learn, I guess, to be able to do all of this and do the kind of coding that you showed today in your presentation.
Yeah. Can you hear me okay?
Yeah, I can.
Okay, great. So it's a great question. It's one I get often. So the conventional wisdom around this is that I'm new to programming. I'm not familiar with programming. Maybe it's not for me. It might be hard. I was in that same position about 7 years ago, and so I kind of learned the hard way, kind of clawing my way to figure this stuff out. And the reason I write so much about this stuff is that I'd like to think that I'm writing to myself 7 years ago. So if I have the fortune to come across a time machine, I'll put that stuff in a time machine and send it back to myself. And so what I've realized over the years is that in the vast sea of object-oriented programming, there are only like 8 things you really need to know to get started with automated web testing, 8 actual programming concepts. And I have a book called the Selenium Guidebook. If you go to seleniumguidebook.com, you can see a sample. There's a free sample there. You just kind of scroll down the page, there's a section for the sample. In that free sample, there is a chapter. It's chapter 4, I believe, and it's called a programming primer. And that will teach you what you need to know to get started. And the sample goes all the way up through writing your first test. Basically, everything I showed here, with the exception of Applitools integration and sauce integration, all that, but just getting something like a hello world test working with a fundamental glossary of understanding around the core tenets of how to do programming for automated testing. I have one sample for Ruby and one for Java, depending on which language you're looking to go with. And so the gist is that when you learn all the concepts and look backwards, it's like, oh, it's not too bad. But when you look at like kind of the list of things and the words you're not familiar with, it can be overwhelming. But what I've tried to do is make it bite-sized, so that in one sitting you can just digest enough information to get started. And the amount of time it takes a person to get through it really depends on their motivation and really depends on their prior experience. But I've taught people with absolutely zero programming skill how to become an automated tester. And I think that pretty much everybody has the aptitude for it if they have the interest in learning it. So if they just have to be presented the information in an approachable way. And that's hopefully what the sample in my book does for that initial chapter on programming.
Okay, can you give that link again, Dave? I think they didn't quite hear it.
Sure, seleniumguidebook.com.
Okay, perfect. And then we're going to go with just one really quick last question, and Brian's going to go ahead and take that, and then we're going to wrap it up. Great job, Dave. This was really educational for everyone based on all the questions coming in. Okay, so the last question is, it's a good one. Does CloudBees actually offer a Jenkins server in the cloud? Meaning, do I no longer have to have a Jenkins server in-house?
Yes, absolutely. So actually the Jenkins instance that Dave demoed during the presentation was in the CloudBees Jenkins Cloud host managed instance. We call that dev at cloud. You can access that, and I will put the link in chat at cloudbees.com/products/Jenkins-cloud. I will look to, again, follow up with a link. In addition, you can procure CloudBees instances from a number of the top cloud providers. CloudBees Jenkins is available on AWS as well as Pivotal Cloud Foundry.
Fantastic. Thank you, everybody, for joining us today. Again, we will be sending out a recording and the slides from today's session. And if you have any questions at all, I will be sort of the point person, getting people in touch with the experts if you'd like to ask them a question. We'll also be